So as we go through these, keep in mind also, one of the reasons why you've been doing all this practice is it's actually laying the foundation for some stuff we're going to be doing later with factoring. And it's actually probably going to be either this week or next week that we get into it. And so these skills that you're seeing here, you're going to be applying them in a different way that's actually going to make your life a lot easier as long as you stay on top of these. All right, so two numbers that add to 5 and multiply to 6. 3 and 2. Right on. Yeah, 2 and 3 is also fine. Number 2. Two numbers that add to 4 and multiply to negative 12. 6 and negative 2, absolutely, yep. And notice here, the 6 has to be positive, the 2 has to be negative. If you had switched the signs, then you'd end up adding to a negative 4. All right, then number 3, we're going to add to 20 and multiply to 19. Number 3 sometimes can be a little bit tricky for people because we look at it and we say, wait, multiply to 19, there's nothing that multiplies to 19. Well, the problem is that we've been trained almost to neglect this one option because there's always something that goes into it, right? 1. Yep. So in this case, 19, we could get it by doing 1 and 19. And notice 1 plus 19 gives us 20. So that is our combination. And finally, for number 4, adding to a negative 15, multiplying to 56, it is negative 7 and negative 8, yes. Now on these, knowing your times tables is going to help. Some of you I know, I say that and the eyes start to roll a little bit and be like, oh yeah, I've always had trouble with those. Well, the nice part is it doesn't have to stay that way. You don't have to always have trouble with the same thing. You're going to be practicing these ideas of numbers that multiply to these things so much. You're going to get to know these numbers that multiply together to give various values better and better and better. But you'll remember them if you're conscious of the fact that you need to be remembering. And if you kind of reflect a little bit on, okay, what do I need to know in order to remember this? And if you do that, that'll help you along the way. All right, we're going to do a little practice from yesterday. Now, you do not need to copy down this graph. That would just take forever if everybody was copying down these graphs. So instead, just follow along up here on the board, and we'll do them up here. So you actually don't have to write anything down for once, which is nice. We're going to write the equation of this graph. This is what we saw yesterday. So the way that we go about doing it is we write the equation y equals, first of all, look at the shape of the graph. This is a V-shaped graph. What is the equation for a V-shaped graph? Absolute value, absolutely. So we know that's going to be the absolute value of x. But in this case, it's not starting at 0 where that would normally start. It's starting down 1. So in order to tell it that it's been moved down 1, that's where we put that minus 1 hanging on the end. And so then that's your equation. Y equals the absolute value of x minus 1. With that in mind, go ahead and now write the equation for this one. I gave you like 15 seconds to think it through, then we'll get it back together up here. Yep, we end up getting y equals x to the power of 2, or x squared, and then minus 2. So we know it's x squared because it's the U-shaped graph, also known as a parabola, if you want to get it fancy with it. And then since the vertex is down at negative 2, that's how we know how far it was shifted down. All right, now for this graph. Again, figure out what the equation is. All right, let's write our equation. Excellent. All right. Yeah, so we take a look at the shape of the graph. It is going to be square root of x. We know that by the shape of the graph. And then because it starts up at 7, it is plus 7 for that reason. All right, nicely done. Now a slightly trickier one potentially. So it is going to be an exponential. So it's going to be y equals 2 to the power of x. Now a lot of us, when we first look at it, think though it's going to be plus 4. But it's not, because where does an exponential graph, where would just 2 to the x normally start? It normally starts here at 1. That's where the first point normally is. The dotted line that you see drawn in there, that's where we're normally at the x-axis. So how far do we have to move it up to get to where they are now? 3. It's kind of tricky like that. This one is one of the trickiest to get down at first. So you really got to take time and think about where would that dotted line be, or how does that first point compare to where it normally would be? All right. How about this one? What's the equation of that one? So on this one, it's y equals the absolute value of x because it's the v-shaped graph. And since our vertex is up at 2, it's plus 2. Nicely done. Okay, what about this one? All right, so this is what we get. We get y equals x minus 7. The reason is because since this is just a line, we know the parent function is just a plain old y equals x. And then we're moving it down 7 because you notice that's where it starts. So that's our whole equation. Last one of the graphs we're going to practice, today at least. I'm betting you already know what the parent function is. What type of equation is this? Cosine, absolutely. The question, though, that is trickier on this one, how far has it been moved? So there's 2 different ways you can look at this to know how far it's been moved up or down. The first way is to think about where is our first point normally for cosine. Normally it's at 1, yeah. So if it's normally at 1, how far did it move up? 2. And so that is in fact how far it's been moved up. It's been moved up 2. But I said there was another way you could look at it. Just to kind of expand your understanding about what else is going on with these. Think about where the middle of this wave is. Normally, our cosine graph is going above and below the x-axis. So that's above and below 0. Notice what's going above and below here. 2. That number that we moved it up by. So, another way to look at that. The last thing we're doing together today is we're going to do a little solving equations practice. So, what I'd like you to do, please, is write down and solve each of these 4 problems. Then after we do these 4 and look at the answers, we're going to do one more after. So for number 1, in order to solve this one out, notice that on the right side we can actually combine some like terms. So before I do anything to both sides of the equation, I'm just going to go ahead and do the 9x minus 3x. 9x minus 3x will give me 6x. So that side is equal to 6x minus 11. Now I have to do stuff to both sides. Now when I do that, I got tons of options. There's different things I can do at this point. But there's one thing I always tend to do first, just as a matter of habit. I always try to move my x's together first. And so I'm going to try to get these 2 together onto the same side. When I do that, I like to make that result positive. So I'm then going to choose to move the 4x to the other side. Because if I subtract 4x from both sides, I'm going to end up with a positive x value still. Now notice that's a personal preference thing. It's not like it's strictly required. It just seems like it makes life a little easier. Now that I've done that, my next step at this point has to be to add 11. Now if you did something different for your first step, this step will be different for you. But the end result of 18 equals 2x will be the same. And so then to solve this, we still want to get x by itself. Right now it's 2 times x. So I'm going to undo the multiplying by 2 by dividing by 2. So we divide both sides by 2 here, so you get 9 equals x. For number 2. Now, for a lot of us here, number 2, we may not necessarily know how to do it algebraically at this point, but that's what I'm going to tell you here in a minute. But you could still figure it out. Because you could still figure out, okay, what number squared equals 81? Or in other words, what number times itself equals 81? And what number is that? 9. So, our final answer is going to be x equals 9. Having done that, I do want to show you how we'd know it algebraically, though. So rather than just jumping to that point, how do we get it? What's the opposite of squaring something?
Square root.
Square root. And so really, in order to get this, this is what we're doing. We're taking the square root of both sides. All right, number 3. When doing number 3, there's actually 2 different ways to do it. The way that I do it tends not to be the way that most people do it, but I want to tell you what it is because it helps with that algebraic knowledge. If I want to get that x by itself on the right side, I might get rid of the 5 first, and the opposite of something being over 5, means it's being divided by 5. The opposite of dividing by 5 is multiplying by 5. So one thing you could do at the start of this problem is multiply both sides by 5. That's the way I always tend to think about it. But just the same in terms of how well it works is you could say, oh, well, 12 is just 12 over 1. Then I can think of it as a fraction equal to a fraction, which means cross multiply. And so if we cross multiply with this, 12 times 5 is 60. And then 3x times 1 is just 3x. Whether you start by multiplying both sides by 5 or by cross multiplying, you get to this same line. And then having that, we can go ahead and solve it out. In order to get the x by itself, I undo the multiplication by 3 by dividing by 3. And so 20 equals x. And finally out of these, number 4. Number 4 scares people because it has fractions in it. But we've been practicing fractions quite a bit recently. You actually can handle this just fine. You just can't let yourself get intimidated by it. Because think about, what if I gave you a simpler example? What if I gave you x plus 2 equals 3? How would you solve it?
Subtract 2.
You'd subtract the 2 from both sides, right? It's the same thing with this one, just it's not a nice pretty whole number on the left side, it's a fraction. But we can still start it by subtracting that fraction, the 1/6, from both sides. So we get x equals, and rather than trying to do that whole subtraction with the fractions all at once, I'm going to start by just writing this as 4/9 minus 1/6. Then I can focus my attention on doing that subtraction. All right, so now I know what x equals, I just got to do the math. In order to do the subtraction of fractions, what do I need first? Common denominator, absolutely. Now, in this case, when you get the common denominator, I saw some people using 36. That works. 18 is even better. So I'm going to make both of these fractions over 18. So on the first fraction, I multiply 9 by 2, so I multiply the 4 by 2. On the second one, I multiply 6 by 3, so I multiply the 1 by 3. And there's my common denominator. Now I can do the subtraction nice and easy. 8 minus 3 is 5, and the denominator has to be the same because it stays the same. And so we get x equals 5/18 for that one. We're going to do one last problem here. This one uses skills that you just used on 1 through 4. There's no special rules or techniques or anything that you need to do on this problem compared to the last 4. So you already know how to do everything that's involved in this, so go ahead and work this one out. And take it as far as you can, even if you aren't sure on the whole thing. So the first thing we do here, just like we did in number 4, the first thing I'm going to do is I'm going to move the numbers to the same side. Yes, they're fractions, but they're still numbers. So in this case, that means moving the 1/8. And I move the 1/8 by subtracting it from both sides. So then on the left side, we got 3/4 minus 1/8 equals 5x over 6. All right, and then we can go ahead and do that subtraction. Now, of course, we need the common denominator, so we turn 3/4 into 6/8. And then we can do the subtraction, so we get 5/8 equals 5x over 6. And now we can solve that. Now, in order to solve that, this one then looks a lot like number 3. Remember how we solved number 3? Use the same technique here. So now we cross multiply. So then I'm going to do 5x times 8, and I'm going to do 5 times 6. And those two have to be equal to each other. Sometimes people forget that part. When you cross multiply, they are equal. So I'll continue this up on the right side, make it easier to see for those in the back. So 5 times 6 is 30. And then 5x times 8 is 40x. Notice we can do 5x times 8 because we're multiplying them. If it was adding, that's the one where we can't do it because they're not like terms, but multiplying, we can do that. All right, so now we just got one more step really to go. I need to get the x by itself. Right now it's 40 times x, so I need to divide by 40. When we do that, I don't really want to get a decimal here because we started with fractions. If you start with fractions in the problem, we want to end with fractions. So I'll just write it as 30 over 40 for the moment, but I do need to reduce it. 30 over 40, of course, reduces to 3/4. That's our final answer on that one then. X equals 3/4.